Okay, thank you for this introduction. And before I start, I would like to thank the organizing committee and Professor Sarkis for setting up this dedicated radiation protection session, and also for inviting me to deliver 2 lectures on radiation accidents and dose optimization in interventional cardiology. In the first lecture, I will be reporting the case of a severe radiation cardiology accident in France, which happened quite some years ago, in which we were involved as the French Authority for Nuclear Safety. That's where I was working beforehand. And I will be really focusing on the dose reconstruction and on the special medical care that is required in the case of radiation wounds. I will finish this presentation with a list of malfunctioning and errors that we have identified while we were inspecting that hospital and trying to reconstruct the accident. And I will also show you some of the immediate corrective actions that were set at the local level and also at the national level. In the second presentation, I will start from this list of malfunctioning and try to focus with you on the dose optimization and how to avoid such injuries. So let's start with the first presentation on the radiation accidents. Actually, reports on radiation accidents in interventional radiology go back to the early 90s, with a special case reported of a deep necrosis with atrophic borders after multiple CA and PTCA, and that's the image actually 18 months after the last procedure. And as the stents and catheters really evolved with more sophisticated solutions, we started, obviously the number of interventional cardiology procedures got higher and higher, with their complexity also being larger. And so reports on radiation accidents, there were quite some many. And here I want to show you one particular paper that was published in 2010 in Radiology following the RSNA meeting, where Stefan Balter reviewed the cases of different radiation accidents and their effect on patient skin and hair. There were tens of accidents reported in this paper, with 2 main focuses. The first one being the time of onset of the effect after the procedure. And the main message is that tissue reactions may appear weeks and even months after exposure. And the second one is really to be aware of the fact that cumulative exposure and repetitive exposition in different interventional cardiology procedures can lead to a drastically increased risk of radiation injuries. Now in France, there were 7 reported accidents between 2007 and 2012. 4 in cardiology, 1 in neuroradiology, which actually involved 12 patients, and 2 abdominal procedures. These were really highly publicized and brought up to light the issue of radiation protection. So the case I want to report today happened in 2011 at Lagny-sur-Marne hospital. It involved an overweight patient who received 6 coronary angioplasties. The time frame was between March and December of 2011. These were obviously extremely complex and long interventions. And after the first 3 interventions, the patient started developing first clinical signs in the form of erythema. But these had somehow a spontaneous healing. But as the patient also received additional interventions, he started developing severe clinical signs. And in March 2012, the French Authority for Nuclear Safety, ASN, was informed of this accident. At that stage, the patient had already developed the skin necrosis, as you can see here on the pictures. And the ASN was really worried about what actually happened, what went wrong, and what was the dose distribution at the skin level and at the organs, especially the heart and the lungs, and also what is the appropriate medical care for this specific radiation accident. So ASN requested the support of IRSN, where I was working, to reconstruct, to investigate the accident, reconstruct the dose, and try to evaluate the dose at the skin level and at the organ level. They also requested the support of Percy Military Hospital to take care with them, to provide the appropriate medical care, especially given their stem cell transplant facilities. So working at IRSN, we had to work on the dose reconstruction for this accident. We had two approaches in this case. In the first case, we considered the use of experimental measurements and Monte Carlo simulations. So starting from simple dose records which we were able to find on the packs, we started to reproduce the different exposure conditions, faithfully reproducing the different interventions. Now this was obviously very consuming and challenging, especially since many of the information went missing. For example, on the packs you can't find the fluoroscopy dose, so this was really a very difficult thing to do. The second approach that we considered was the use of biological dosimetry. In this case, we used blood samples and we tried to count single and double strand breaks of the DNA. We also used electron paramagnetic resonance. I will show you the results for this. So actually what we did was to take out a sample of bone from the back of the patient, and we tried with the EPR to estimate the dose to the patient. This is a rather new technology. We were testing it for the first time on a patient. So this is just a summary of what we found in the dose, at least in terms of peak skin dose, so the highest dose to the skin. So in the first, this is the list for the 6 interventions, and as you can see, the dose changed or was very large, from 2 to 17 grays. If you add up this dose, in total, the patient received at the skin level 60 grays. That's obviously radiotherapy. That's no longer radiology. So that was one of the answers that ISN requested. What was the maximum dose, and how does this dose distribute on the skin level? The second question was, what about the organ doses? So we made Monte Carlo simulations by taking the CT scan of the patient and then remodeling the patient and starting over with all the procedures. So what we found is that there is obviously a big decrease of the dose in depth. That's because the energy of the X-ray is rather low. And in terms of the final dose or the total dose to the heart and to the lungs, it was between 1 and 3 grays. So this is, let's say, not a big deal. Okay, I shouldn't say it, but at least it doesn't mean that the patient requires a specific treatment for this. Now, as for the EPR dosimetry, so we took 3 different bone samples from the scapula, and we found that the dose to the bone was somewhere between 25 and 85 grays. So bottom line here is that if you repeat exposure, you could end up with doses equal to radiotherapy, so really be aware of this. Now, what about the medical care? Actually, when the patient started developing the first clinical signs, he went to his personal doctor, who treated the injury just as a regular burn. Obviously, that didn't work, so in 2012, the patient went to St. Louis Hospital, where he had a better dermatological treatment to limit the extension of the lesion. Now, as we were able to calculate the dose or reconstruct the dose to the skin and to the organs in depth, Percy Military Hospital performed in 2013 a widespread skin excision and muscle flap. And then they performed a stem cell transplant so to enable the patient to recover a normal skin. So the accident was very severe, 4 out of 5 on the NIH scale. And actually this accident, as I said, was one of the 7 reported, but it raised the question of how many non-reported accidents. Maybe not that severe or this severe, but there were definitely a lot more to come. The problem is that it went really highly publicized, so it increased the risk perception in the general public. We started receiving complaints and emails and regular mails requesting from patients requesting to know what their dose was there a risk or not. And this also raised the problem of accountability. So when it comes to the malfunctioning and the corrective actions, one of the main learning that we found from this inspection was that the protocols that were used were not optimized. There was also an inappropriate use of the X-ray equipment and insufficient training and bad practice on the equipment. There were also deficient X-ray QA program. There was a poor knowledge of radiation risks for the operators at least. And there was no patient follow-up procedure, no local DRLs, alert levels, or even a dose registry whatsoever. So actually what I didn't say is that out of the 6 interventions, we only found 3 on the PACS. They didn't even save the dose at that time. Now this brought immediate corrective actions at the local level, so all operators had to do a dedicated patient radiation protection training. They also had to request the support from a medical physics consultant to set up optimized acquisition protocols and also to train all their operators and cardiologists on the best way to use their equipment. At the national level, there was a massive reinforcement of the regulations, making the dose registry mandatory, setting up DRLs for interventional cardiology. There were also a massive reinforcements of the inspections at the French authority, a new QA requirements, and new quality assurance program, and new training obligations for cardiologists and interventional procedures. So just to summarize, so skin injury severity increases with dose. There is an extra caution that is needed for repeated interventions. For a single procedure, noticeable skin change are observed approximately 1 month after a peak skin dose exceeding several grays. Usually we take the alert level or the alert threshold at 3 grays. A specialized wound care is needed when the dose exceeds 10 grays. On the failures and errors or malfunctioning, we have noticed that non-optimized acquisition protocols, insufficient training, and bad use of equipment can lead to severe radiation injuries. On the corrective actions, we saw that dedicated training, medical physics support, and massive reinforcements of the regulations is needed. Now, just to finish with a slide or a perspective, actually, after these incidents, the manufacturers and X-ray developers have become aware of the need for operators to really know or acknowledge in real time the dose to the patient. Those dose indicators that are given by the system, they don't mean much for most of you. You don't understand what a DAP means, or does it really necessarily mean a high dose to the skin. So they've developed some new skin dose mapping solutions. There's, to the left, you have the GE dose map, and to the right, the Toshiba dose tracking systems. And almost most of the manufacturers have their own solution. So these are useful tools that could guide you through the process and tell you if you have a very high dose to the skin. The problem is that these software are new and they're not benchmarked. So we have a new project, a new EU-funded project, which is called Verdict, in which we will be benchmarking different types of solutions and validating their calculations of skin doses. So that's all for the first presentation. Thank you.